Let's see what's going on visually, right? So here's my two vectors u and v. So u was 3, 5, so 0.35 here, and then v was 2 minus 3, so that's over here, right? Now, to understand what's going on visually, it's very helpful to just look at what we call the resultant vector. So like, what happens when you actually add them together, right? 5, 2, where is that going to end up? Well, it's going to be 5 across, 2 up, so it'd be something like here, right? 5, 2, that's u plus v. Can anyone see that, like, what's kind of going on here visually when you think about the vectors? Like, algebraically, yeah, I'm just adding the horizontal and vertical components. But visually, what's the relationship between these two black ones and leading that blue one? Using hand actions. Oh, that's it. Right, okay. So if I could just like cut and paste this boom, boom to there. We call this aligning the vectors tip to tail. And why does this work, right? We'll go back to what we said at the beginning. Vectors are always equal as long as the magnitude and direction are the same. So it doesn't matter where you put this vector on the Cartesian plane. As long as it's the same magnitude in the same direction, then it's still the same vector, right? So this is still the vector v. And so when we align this way, tip to tail, this is how we can interpret it visually or geometrically. This is also something called the triangle law. The triangle law is kind of saying, okay, if you put them tip to tail, the addition of the vectors u plus v is going to be the side which kind of completes this triangle over here, okay? Let me just show you another perspective of that. Here's without the coordinates. Let's just get rid of that, right? Without the coordinates, have a look at this, right? So you see these two vectors here, they're just kind of like anywhere at the moment. We can move them around or whatever, but they're still the same vector no matter where they are. But aligning them tip to tail allows you to see the addition much more clearly, because when we show the sum, right, u plus v is essentially saying, it's kind of like going along a path, right? I'm going along this u and I'm going up v. Okay, where is this going to match up? And it doesn't matter where u and v are in their original positions, aligning them tip to tail will allow you to see the sum much more clearly. That's called the triangle law, right? The parallelogram law is slightly different. Can anyone see the difference between this arrangement and the one before? This one? Tail to tail, right? And tail to tail again, right? It doesn't matter where the vectors are aligned, as long as they are the same magnitude and direction, then the same. So this way you can align u and v differently if you'd like to, just to see that they are the same. Now, the idea is, again, certain laws for certain situations. So in a situation where we have tail to tail, if I construct a parallelogram, okay, where is, yeah, I didn't do that. I can't claim credit for that cool animation. Where would u plus v end up? Between them? Which one? Yeah? That one? Why?
You ask why. That's just both situations you had to
Yeah, right. So you can think of this in two ways, right? You can think about moving this guy just like back to there, right? Or you can also think about like just like, and then using the triangle law, which would create that diagonal. Or you can think about it as like, yeah, again, following a path, right? If this v goes to here, we're just following the path that way, and that is in fact what it is. And so the reason why they call it the parallelogram law is because it creates this diagonal when it's tail to tail in this parallelogram situation. Which one do you prefer, sorry? Which one do you reckon makes? The tail to tail? Yeah, so again, certain situations. So like if the vectors are lined up this way, it's easier sometimes to think about it as a diagonal. But like you said, you can always go back to the triangle law, tip to tail if you prefer that, right? It's being aware of both of them, yeah. Okay, so that's addition and subtraction.